Assalamu alaikum, dear students. Our today's topic is for class 12th, subject physics, and the topic is torque on dipole in uniform electric field. In the previous lectures, we have discussed about the field intensity on the axial line of dipole as well as the field intensity on the equatorial line of dipole. We have already discussed about the torque. What is the torque? Now, today we will discuss about torque on dipole in uniform electric field. So here we consider an electric dipole. We know that an electric dipole is a system of two equal and opposite charges. So here we have a positive charge and negative charge, and the separation between the two charges, that is 2L, which is known as the dipole length. Now this electric dipole is placed in the external electric field. Now this external electric field is made by some other arrangement, but we don't bother about the arrangement. But that arrangement, creates an electric field in this space in the form of electric lines of force. We know that here we have the parallel field lines. So these field lines are parallel to each other. So that means it's a uniform electric field having strength E. So having strength E. Now this electric dipole, which is placed in this uniform electric field at an angle theta. Here. So we have to calculate two things here. Number one, the net force acting on the dipole. So when the dipole is placed in the uniform electric field, what is the total force acting on the dipole? Number second, we have to calculate the torque acting on the dipole. First of all, we will calculate the net force acting on the dipole. So here, net force acting on the dipole. Net force acting on the dipole. So this dipole is made of two charges. Number one, positive charge, and number second, negative charge. So that means the force will act on both the charges. So वही हम यहाँ पर निकालेंगे. First of all, we will calculate force on minus Q or plus Q charge. Force on plus Q charge, that will be equal to. So we know that. So here it's a plus Q charge. So here electric field, we know that electric field that's created from positive charge and moves towards the negative charge. So that means when it's a positive charge, so this positive charge will repel this charge in this direction. So it will exert force on this charge in this direction. And also this negative charge, it also creates force on this and moves and attracts this charge in this direction. So we can write here this force is equal to plus QE. We have already calculated the field intensity. We have already defined the field intensity at a point. So that field intensity E is equal to, that's equal to force acting on the charge. Or you can calculate here force that is equal to QE. So we can write here the force acting on this charge, this particle, that is equal to plus QE, because it is due to the plus Q charge. The force experienced by the plus Q charge. So we can write here force on the plus Q charge, that is plus QE. That's plus QE. Similarly, the force experienced by this negative charge. So we have here the positive charge. So it's the positive charge and it's the negative charge. So this positive charge will attract this negative charge in this direction. So here similarly, here we have negative charge. It's the negative charge. So this negative charge will repel this negative charge in this direction. So here force will be equal to minus QE. So similarly, we can write here force on minus Q charge, that is equal to minus QE. Now what is the total force? अब यहाँ पर हम देखेंगे what is the total force acting on the body of the dipole. So total force जो होगा, net force अगर हम कहेंगे यहाँ पर, net force that will be equal to, अगर आप देखेंगे, so that will be equal to 0. So when the net force is 0, अगर net force 0 है, net force जो है that is 0. So that means there will be no linear motion of the body. So we can write here no linear motion of the dipole. No linear motion of the dipole. So there will be no linear motion of the dipole. So we have already discussed about two things. Number one, when there is the net force. So when there is the net force, the dipole will move in a straight line. The body will move in a straight line. Here आप देख रहे हैं यहाँ पर कि net force that is equal to 0. So that means that no linear motion. There will be no linear motion of the dipole. But number second, when there are two forces, when there are couple of forces, then at that time the body will rotate. Body will rotate. For example, if we take the example of a running fan, if I ask you, is this fan is running? तो आप कहेंगे yes it is running. But if I ask you after running why it has gone, so your answer will be so it has not gone anywhere. So but it rotates due to the couple of forces. So जो fan जो है it rotates, it runs due to the couple of forces. Similarly, जैसे अगर if the net force will be there, if there will be net force, so there will be the linear motion of the body. If there is no net force, there will be no linear motion of the body. Now we have to calculate the couple, so we have to calculate the torque. Next we will calculate the torque. टॉर्क तो आपने ऑलरेडी पढ़ा है, टॉर्क के बारे में आपने ऑलरेडी पढ़ा है. तो बट व्हाट आर द कंडीशंस ऑफ टॉर्क वो देखते हैं यहां पर. टॉर्क सो फर्स्ट ऑफ ऑल इसके लिए टॉर्क के लिए जरूरी है कि वी हैव द कपल ऑफ फोर्सेस. सो कपल ऑफ फोर्सेस बट वो कपल ऑफ फोर्सेस क्या होने चाहिए, वो ये होने चाहिए इक्वल and opposite, equal and opposite forces acting at different points, acting at different points, creates torque. जैसे आप यहां पर देखेंगे इक्वल एंड अपोजिट फोर्सेस. जैसे इक्वल एंड अपोजिट फोर्सेस आप देख रहे हैं यहां पर वी हैव पॉजिटिव चार्ज एंड वी हैव नेगेटिव चार्ज. नो द फोर्स एक्टिंग ऑन दिस plus q charge, the direction of this force will be this direction because it's a plus q charge. It exerts the force on this, so it repels this plus q charge in this direction, so direction of force will be this in this direction. Similarly, we have negative charge here, so this positive charge it attracts this negative charge towards itself, so we can say the direction of force will be in this direction. So we have two जैसे आप देख रहे हैं 1 and second, so two equal and opposite force, but we have the uniform magnitude, we have the uniform electric field, we have here uniform electric field and the charges have the same magnitude, so we can say so जितना force यहाँ पर होगा उतना ही यहाँ पर भी होगा, so we can say two equal and opposite force, दो equal and opposite forces यहाँ पर है, creates at different points. जैसे आप देख रहे हैं यहाँ पर create हो रहा है और यहाँ पर create हो रहा है, different points पर create हो रहा है and forms torque. और यही torque अप्लाई कर रहे हैं, टॉर्क क्रिएट कर रहे हैं यहाँ पर. जैसे मैंने आपको कहा कि जैसे फैन जो है इट मूव्स, इट इज रनिंग, सो बट इट डजंट गो एनीवेयर, सो वी कैन से इट रोटेट्स ड्यू टू द कपल ऑफ फोर्सेस. नो वी हैव हियर सो टॉर्क, देन वी कैन राइट हियर टॉर्क. So torque is represented by this notation that is equal to, आपको मालूम है कि आपने ऑलरेडी डिफाइन किया है कि टॉर्क जो है दैट्स द प्रोडक्ट ऑफ either product of the force, that's the force, so we can write here F into distance, that's the perpendicular distance between the two forces. So we'll see here, so we write here that perpendicular distance, we'll write here R, so or we can write here this torque that is equal to force. तो force हमारे पास है that is equal to QE into, so this is the distance, this is the perpendicular distance, it is the perpendicular distance. So this is the perpendicular distance, or we can write in this way, it is the perpendicular distance, perpendicular into perpendicular distance. Now we will see this perpendicular distance. That perpendicular distance is between the two forces. जैसे आप देखेंगे यहाँ पर, so this is one of the force, this is the direction of force. ये एक direction of force की direction है. So this another direction of force. So the perpendicular distance will write here. This will be this. So this. So it is A. Write it as B. So here आप यहाँ पर नाम रखेंगे इसका B. So this is plus Q charge. ठीक. So नाम यहाँ पर रखेंगे C. ठीक. So this AC, that is the perpendicular distance between the two forces. So here it's the negative force. आप कहेंगे इसको negative force कहेंगे आप, because it is on the minus Q charge. इसको आप कहेंगे positive force. यहाँ से आप कहेंगे positive force कहेंगे. ठीक. So it's due to the force of repulsion, it's the force of attraction. So and this is the perpendicular distance between the two forces. So we'll write here tau is equal to, tau means torque, that is equal to force, that is Q E into perpendicular distance, that is BC, that is BC. Now we will calculate this BC. What is this BC? So we have a right angle triangle here. We have a right angle triangle here. So in a right angular triangle, तो हमारे पास right angle triangle है. So that is ACB, ACB. So this is the perpendicular. हमें perpendicular चाहिए. तो हमारे पास already यहाँ पर hypotenuse है. So that hypotenuse is 2L. That is the separation between the two charges. Separation between the two charges. So we have 2L here. So 2L here. We can write here. It is 2L. That's the dipole length. Then if we have to calculate the perpendicular, and the hypotenuse is given. So we will apply the sine theta. We will apply trigonometric ratio, that is sine of theta, that is equal to perpendicular divided by hypotenuse. So sine of theta is equal to, perpendicular is BC divided by hypotenuse, that is AB, or we can write sine of theta is equal to BC. So BC we have to calculate, divide by AC, that is 2L. Or we can write here BC is equal to, we will multiply here, so this will be twice L sine of theta. Twice L sine of theta. So we have expression here, expression A. Put this value in equation second equation, in equation A. So right here tau, that's the torque, is equal to QE into BC. What is BC? That is 2L sine of theta. Or we'll write here tau, that is torque is equal to, so we know that this Q into L into 2, so that's the dipole moment. We have already discussed about the dipole moment, that is P. So we'll write here P, that's the dipole moment. E is sine of theta. So here we will write here Q, this Q. So here we will write here Q into 2L, that is the dipole moment. So this is the expression for the torque acting on the dipole. We can write this expression in terms of cross product, vector product. In terms of, because we know that आपने ऑलरेडी डिफाइन किया होगा 11th क्लास में, क्रॉस प्रोडक्ट किसको हम कहते हैं, इसको वेक्टर प्रोडक्ट कहते हैं. दैट्स द प्रोडक्ट ऑफ two vectors and sine of the smallest angle between them. So we can write in this way. If we have tau here, that is equal to, so we have expression P E sine of theta. We can also write it as tau is equal to, so P cross E, P cross E. So इससे हम ये डिफाइन कर सकते हैं कि टॉर्क जो है दैट इज अ प्रोडक्ट ऑफ, दैट इज अ क्रॉस प्रोडक्ट ऑफ डाइपोल मोमेंट एंड द इलेक्ट्रिक फील्ड, dipole moment and the electric field, but the basic expression is this. So this is expression B. So this is the expression for the torque. This is the expression for the torque. So in case of torque, the body will rotate, but there will be no net force. There will be no net force. So we'll see here what are the special conditions, what are the special cases here. Special cases. Special cases. Special cases. Special cases. Case first. Case first. Yeah. Now, if this theta is 0, if this theta is 0, means when the dipole is placed in this uniform electric field at an angle of 0 degree, इसे हम इस तरह dipole को place करेंगे. What will the net torque? We will see what will the net torque. So if theta is 0 degree, ऐसे मैंने आपको कहा कि if it's an electric dipole, it's placed in the uniform electric field in this direction. इस डायरेक्शन में हम इसको प्लेस करेंगे इलेक्ट्रिक फील्ड में. तो we'll see what will the net torque acting on the dipole. So if theta is equal to 0, theta जो है that is the angle between theta, that is the angle between dipole moment P. So it's the dipole moment and this is the electric field. So we can write here tau is equal to in this expression P dipole moment. So here it's the electric field. So into E into sine of 0 degree. So tau will be equal to, so this will be equal to 0. So that means at that time, so no torque acts on the dipole. Second case हम लेंगे यहाँ पर, case second लेंगे, second case लेंगे, case second. So if theta is equal to 90 degree, अगर theta 90 degree होगा, so that means this dipole, this electric dipole is placed in the uniform electric field at right angle perpendicular to the uniform electric field in this direction. So we'll see here what will be the torque. So in this case torque will be equal to P E sine of 90 degree. So here we know that this sine of 90 degree, that is 1. We can write here torque is equal to P E. So that means that's the maximum torque, P dot E, P cross E. So it will be P cross E. So it means that when the dipole is placed in the uniform electric field at right angles to the electric field, so maximum torque will be experienced by the dipole. I hope you will like this video.